Okay dear students, sorry for the interruption. So that I am just going to write the values again here. So dear students, you can observe it carefully. So that Vi is equal to d by dt of, here x is there. What is x which was given in the question? Found to be equal to 2t square plus 3, my dear students. Right? So now Vi is equal to, I am just multiplying this d by dt with 2t square and d by dt with 3. So let us see that d by dt of 2t square plus, I am just again multiplying the d by dt into 3 becomes d by dt of 3. Now in the part 6 video in the previous class I just discussed some of the formulas of calculus from the mathematics, so that I am writing it on the board. You can observe that the formula d by dx of x power n can be written as n into x to the power of n minus 1, and d by dx of a constant is equal to 0. So that, my dear students, you can observe very carefully that here d by dt of 3, that is what 3 is a constant, so that the differentiation of 3 becomes equal to 0. So this term is going to that term is going to vanish. The remaining is Vi is equal to d by dt of 2t square. Dear students, 2 is constant, take it outside, so that Vi is equal to 2 into d by dt of t square. You can observe that in place of x we have t and in place of n we have 2, right? So that now let us use the formula 2 into. So here n into x to the power of n minus 1. In place of n we have 2 here, and in place of x we have t. Here n minus 1 is there. In place of n I am writing 2 minus 1. Right? 2 minus 1 is 1 again. That is what? 2 into 2 is 4 into t. So we got this equation. But still we not yet calculated instantaneous velocity. Dear students, instantaneous velocity is equal to 4 into t. In how many seconds they given? In 5 seconds. So that substitute t is equal to 5 seconds. 4 into 5. So 4 into 5 is 20. Whereas the SI unit for the velocity is meter per second. So that we calculated the instantaneous velocity. So now let us move for the calculation of instantaneous acceleration. My dear students, also we have written the formula for the instantaneous acceleration. So that the formula for the instantaneous acceleration, AI can be written as dv by dt, that is change in velocity with respect to the time. So that AI can be written as d by dt of. See, while solving this, I just got the instantaneous velocity which is equal to 4t, right? This is what I got. So this is what I got. So in place of v, I am just writing it as 4t. I am just writing it as 4t. Suppose, dear students, assume that, first let us see that, afterwards I will explain that. Okay, AI is equal to 4 is constant, take it outside. So remaining is d by dt of t. T to the power of 1 is there. So nothing is there, it indicates that there is a power 1. So I am differentiating this by using this equation. So in place of x we have t there, and in place of n we have 1 there. So now instantaneous acceleration I can be written as 4 into so t power 1, right? So I am just writing this. So in place of n we have 1 into, in place of x we have t, and in place of n 1 minus 1 according to the formula. 1 minus 1 is 0. So that's 4 into 4 ones are 4, t to the power of 0. Anything to the power of 0 is 1. So that becomes equal to 4. So that the acceleration is having an SI unit, that is meter per second square. So that the instantaneous acceleration is found to be equal to 4 meter per second square. Dear students, suppose if we not have still calculated this instantaneous velocity, instantaneous velocity calculate ಮಾಡಿರಲ್ಲ. by the time we should move for the calculation of acceleration. Then how to proceed with? So we should by the time we should move for double time differentiation. Even I can just show you how to do that double time differentiation, my dear students. So that here, suppose we still do not have calculated, assume that we do not have calculated. So that this d by dt will be as it is. What is this velocity? It is again can be written as dx by dt, right? So this is how to calculate. So and then we can proceed with the calculation of x, that as we did in the previous numerical. That is what? Point number 2. Yes. Now let us move to the next numerical, dear students. Okay. Hope you are all taking down the question. Now let us move to the next question, dear students. So here in the PDF that what I uploaded, the question number is 5. See, I am just mentioning the question number and reading out. So just observe that the PDF, right? So a player throws a ball upwards with an initial speed of 29.4 meter per second. See the what player is going to do? The player is throwing a ball upwards. See, player is going to throw the ball upwards. The player is going to throw the ball upwards. Right. So with how much speed it is throwing? 29.4 meter per second. It means the initial velocity u is 29.4 meter per second. This was the condition they given. Now, in this we have again 3 parts of question. The first question is, what is the direction of acceleration during the upward motion of the ball? My dear students, here first question is, what is the direction of acceleration during the upward motion of the ball? You know that the ball is thrown upwards, but here we have earth. Here we have earth, right? You know that earth is having its own acceleration due to gravity g. Whatever the object which is thrown upwards, what happens? So due to the gravitational force, it is attracted towards the center of the earth. So that easily we can say that for the question number 1, the acceleration of the ball which is thrown upwards is always towards the earth, towards the center of the earth. It is exactly in the downward direction. Hope you got for the first question. And the question number B was like this. What is the velocity and acceleration at the highest point of its path? See, the question number B I am just solving here now. What exactly this question number B is? We should calculate the value of velocity at highest point. It means assume that I just thrown a ball. It has reached some point. So say this point has the highest point. It has reached this highest point. When the object reaches the highest point, so you know that at the highest point, always the velocity is 0. So that easily we can say that at highest point, the velocity is 0 meter per second. Now, the object is at somewhat height. The object is at somewhat height. It has reached some height. It means earth is always, it is going to attract this object, as well as there is a force of gravity which is pulling it downwards, whose acceleration is acting downwards. So that my dear students, the acceleration is equal to acceleration due to gravity. So that acceleration A is equal to g. No need to explain a lot of things for this. For free falling object, or the objects which are thrown upwards, or the objects which are allowed to fall under the action of gravity, for all those objects the acceleration A is always becomes equal to g. So that the acceleration A is equal to g. So then what is this value of g? So you know that the value of g is 9.8 meter per second square. Hope you solved this question number B also. Now the last question, that is what question number C, which was given here. So now let us see the question number C. So it was like to what height does the ball rise and after how long does the ball returns to the player's hand. So here again I am reading to what height. So the to what height the ball reaches, it means h is equal to question mark. Actually it is going to rise from ground to the highest point. So we should calculate the h. And again, and after how long does the ball returns to the player's hand. See, I am just going to throw the ball. I am just going to throw the ball. So just want to do this. Okay, I am just going to throw the ball. So this is highest point, right? So it takes time t1 to move from ground to this position, right? And afterwards, and it takes the same time said to be t2, where t1 and t2 are equal, to reach the ground. So it means the total time to reach back to the player's hand is equal to t1 plus t2. This is what we should calculate. Hope you are getting it. Dear students, first let us move to the calculation of h. So to calculate the height h, here they given the value of u. Let us write this. What is u? They given u is found to be equal to 29.4 meter per second. And at highest point, the final velocity is 0 meter per second. Right? And what is the acceleration? Is equal to minus 9.8 meter per second square. Why it is minus? As I said you before, if the object is coming downwards, a is equal to plus g. Suppose if the object is moving upwards, a is equal to minus g. So here the object is thrown upwards, so that a becomes equal to minus 9.8 meter per second square. Now to calculate h, we have two formulas. H is equal to ut plus of gt square, and the next one is see I am using gt square. Why? Because here it is for free falling object. It is for which one? It is for free falling object. So that my dear students, otherwise even we can use v square minus u square is equal to 2as. So also what we should calculate? T is equal to t1 plus t2 is equal to question mark. See, whereas t1 is the time required to reach the highest point from the ground, and t2 is the required time to reach the ground from the highest point. So dear students, this time t1 is called as, this time small t is total time, t1 is time of ascent plus t2 is time of descent. Time of ascent plus time of descent. Now let us move on for this calculation of h. So the formula is 2ah is equal to v square minus u square, because for this free fall objects, right? So now I want to calculate h. Keep h as it is, and v is 0. So if v is 0, this becomes 0. Remaining is minus u square divided by 2 into a. So now let us substitute the values. Minus u square. U is 29.4 whole square. It means 29.4 into 29.4 divided by, here it is 2a. 2 into minus 9.8. So minus 9.8. So minus cancel with each other. So h is equal to 29.4 whole square divided by 9.8 into 2 is 19.8. 19.6. Yes, 19.6. So now use your calculator just to calculate this. First multiply 29.4 into 29.4. You will get the value, and divide that by 19.6. So that the final height turns out to be equal to 44.1 meter. So that the height is equal to 44.1 meter. So finally we calculated the height, which was or the distance travelled by the ball, or the height which was covered by the ball which is thrown upwards. Now let us move for the calculation of total time. So I am just moving for the calculation of total time, dear students. So to calculate the total time, first I should know the value of T1 and also I should know the value of T2. So to calculate this, now we have the height h. Then we can move in two different formulas for the calculation of the time, or else even we can move with a simple formula, that is V is equal to U plus AT. Right. Now, otherwise simply you can write here V is 0, right? V is 0 here. Why? Because at highest point V is equal to 0 meter per second. So rearranging the terms. So if I shift this towards this side, minus U becomes equal to plus 18. So I am just writing it as T1 for one side of journey. So T1 is equal to minus U by A. I am shifting this A towards this side. So then T1 is equal to minus U is 29.4 and A is minus 9.8, minus cancel. So 29.4 divided by 9.8 gives you 3. So that what is this saving for time? It is second. So that we got time T1 is equal to 3 seconds. But still we have not yet completed the numerical. Why? Because here we have two times we should calculate. We know that the time of ascent and time of descent both are same. Therefore, T1 is equal to T2 is equal to 3 seconds. Finally, the total time T is equal to T1 plus T2, that is time of ascent plus time of descent. Time to move towards the highest point and time to come back to the original position. 3 plus 3, so that the total time T becomes equal to 6 seconds. Right. So this is what the solution for the required question. Okay, dear students, hope you all got clear about how to solve the numericals. First, we read the question 1 or 2 times and write the given values first and check out the formulas. What are the formulas are there? In those formulas, which formula is best to use for this situation, and move for the solution. And in the PDF notes that what I uploaded, my dear students, for initial velocity, I represented it as initial velocity U is represented as V0 and the final velocity V is represented as V in that one. Right. Don't confuse with the thing. So that I have shown you all the types of method. I have shown you all the types of method. Just go with that and also follow that what I am exactly teaching here. Right. Okay. Thank you, my dear students.